Greetings, math fans. All right, we're going to cover the review sheet, and it's a lot of problems, but you guys should be pretty good with these. All right, so this is the key. All right, so simplify the radical expression. So remember, guys, when you're doing fractions, if you can write it as 1 square root and then simplify it, do that, and I can. So square root of 21 over 3 is the same thing as square root of 7. Okay. Next one, again, I don't have to worry about the square root on the top, but I do have to simplify it. So that's 5 times 4, so it's 2 root 5 over 10, and that is a 1 and a 5, so it's root 5 over 5. Okay, remember, you can't simplify anything that's under a radical with anything that's not under a radical, so that's your final answer. Okay, this one, I can write it as square root of 4 over square root of 5, which is 2 over square root of 5, and then rationalize it. So root 5 over root 5, so it's 2 root 5 over 5. Okay, again, looks like nasty numbers, but if I write it all as one fraction, square root of 300 over square root of 500, I can simplify that, and I get square root of 3/5, and then kind of rewrite it again as square root of 3 over square root of 5, and then rationalize it. So I get square root of 15 over 5. Okay, this one, man, is really easy. It's square root of 25 over square root of 16, which is 5/4. Okay, this one, not quite as easy, but not too bad. I'm going to simplify the top is, well, two ways I can do this. One is you guys can recognize the square root of 49, which is 7. And the square root of 28 is 4 times 7, so it's 2 root 7. And then I can rationalize it by multiplying it by root 7 over root 7. So I get 7 root 7 over 14. And then that's a 1 and a 2. So I get root 7 over 2. Now that's your final answer. Now if you also recognize, I could have done 49 and 28 simplify. So let's look at it another way. I could write it as 49 over 28. So 7 goes into 49 7 times. 7 goes into 28 4 times. So I could have rewritten it as square root of 7 over 4, which actually is really easy because isn't that the square root of 7 over the square root of 4? And what's the square root of 4 is 2. So I got the answer both ways. I actually think the second way was easier as long as you recognize that you could reduce that fraction. Okay, square root of 156, again you're using your calculator, and the first number that goes into that is 4. So it's square root of 4 times 39. 39, can't do anything with it, it's just 3 times 13, so it's just going to be 2 root 39. Okay, the next problem, as opposed to multiplying 3 times 6, which isn't too bad, you could say that's the square root of 18. How about if I just say 2 times 4 is 8, and 6 is 3 and 2. So I pull a pair of 3's out, so I get 3 times 8 is 24, root 2. Okay, square root of 565, can't really do much with that. You could say that's just going to be 5 times 113. And 113, you can't really do much with that, so the answer is just going to be root 565. Okay, just because you can't simplify it, don't leave it blank, okay, or don't put a question mark next to it. I mean, you actually need to figure some stuff out here and put an answer in the blank. All right, so don't just panic right away because sometimes that happens. All right, and of course you try to simplify the 113 also if you could. You know, divide it by 9 and just see if anything happens, and actually you can't. It doesn't do anything. All right. Square root of 40. It's going to be 4 times 10, so that's 2 root 10. Negative square root of 144. 144 is a perfect square, so it's negative 12. Remember, guys, I would try a number if it's a big number. See if it's a perfect square. Type in your calculator, because I could give you some evil, nasty number, and all you have to do is hit the square root button. It could be the answer. So try that. All right. Next one is 25 times 2. Square root of 25 is 5. 5 times 6 is 30 root 2. 400, I guess what I would do is right away is I'd say, well, I know that's 4 times 100. And actually, square root of 400 is a perfect square, but if you didn't know that, which you should try it in your calculator, okay, you could do it this way, and the square root of 4 is 2, square root of 100 is 10, 2 times 10 is 20. Okay, 75, it's negative, so put the negative on the outside. And that's 25 times 3. So take the 25 out, and we get negative 5 root 3. Okay, 128. Again, you know, you're trying 4. So if I did 128 divided by 4, I got 32. So let me write that out. 32 times 4. Well, you should recognize you can do more than just, you can take another 4 out. In fact, if you can recognize this, you can take a 16 out. 16 times 2 is 32. Okay, and again, it doesn't matter. If you did 4, let's just do that. I said that's 8 times 4. Times 4. Well, 8's, again, I can do 4 times 2 times 4 times 4. That's as simple as possible. And I can take a pair of 4's out, and I have a perfect square, just 1 4. So if I do that, I have 2 is the square root of 4. Taking a pair out is the same thing as 4, and I have a 2 left over. So I have 8 root 2. And the simplest way to do that was actually 2 times 64. Okay, what's the square root of 64? 8 with the square root of 2 left over. Okay, so the faster you can do it, the better off you are. But if you go, you know, it takes you a little while to get a couple of numbers, that's okay. It doesn't really matter as long as you get the right answer. Okay, I could multiply these together, but I'm going to simplify this here. So it's square root of 3 over square root of 5, square root of 1 over square root of 4. Isn't that just 1/2? So I multiply these together, square root of 3 over 2 root 5. And then I rationalize square root of 5 over square root of 5. So I get square root of 15 over 10. And that's your answer. All right. Number 17 is you're distributing that square root of 5. And as opposed to saying 5 times 15 and trying to simplify from there, why don't you just write it this way? 5 times 5 times 3 plus multiply this guy. Again, guys, don't give me the square root of 25. Square root of 5 times square root of 5 is just 5. So this one I can pull out a 5. So I get 5 root 3 plus 5. And you can't combine those because they don't have the same radicand. Okay? Next one, root 2 times root 2 is just 2. So it's 3 times 2. Plus root 2 times root 5 is root 10. So it's 6 plus root 10. Okay, the next one I'm going to distribute. So I get 2 times root 6. Is that 3 times 2? And then you got already a 3 there. And it's minus 4. And 6 is 3 times 2 and then 2. So I never really actually multiplied that 6 together by those numbers because I'm going to be able to take something out anyway, so why multiply it all out? This makes it easy. I got a pair of 3's here, so it's 2 times 3 is 6. And I have a pair of 2's, so 4 times 2 is 8. And that's your answer. Okay, 20 is easy schmeezy, man. Square root of 15 squared is 15. Okay, 4 root 7 squared. That's 4 squared times root 7 squared, which is 16 times 7 which is 112. Okay, 10 root 2 squared, so it's 10 squared times root 2 squared. So it's 100 times 2, which is 200. This one, don't forget guys, write it twice, man. So it's root 3 plus 2, root 3 plus 2, and then you FOIL. Root 3 times root 3 is 3. Root 3 times 2 is plus 2 root 3, plus 2 root 3, plus 4. So 3 plus 4 is 7, plus 4 root 3. Okay, same thing. 3 root 2 minus 1, 3 root 2 minus 1. So 3 root 2 times 3 root 2 is 3 times 3 is 9. Root 2 times root 2 is just 2. So it's 9 times 2 is 18. Minus 3 root 2 minus 3 root 2 plus 1. So it's 18 plus 1 is 19 minus 6 root 2. Okay, this one's FOIL. Notice it's really a difference of two squares, guys. So what's going to happen is the OI is going to cancel the inside outside, or outside inside, right? So root 7 times root 7 is 7. Root 7 times root 3 is plus root 21. Inside minus root 21. And last minus 3. 7 minus 3 is 4. And these guys cancel, so your answer is just 4. Okay, not bad. Root 14 times root 6, as opposed to multiplying that together, I'm going to do this. 14 is 7 times 2. Root 6 is 3 times 2. Pair of 2's comes out. So I have 2. 7 times 3 is 21. So 2 root 21. Okay, same thing here. I get a 3 on the outside because it's just 3 times 1. So it's 5, and 10 is 5 and 2. So I pull a 5 out, and I get 15 and a root 2 left over. Okay, I'm going to leave that 7 just hanging out there, and I'm going to deal with this. Isn't that the same thing as square root of 20 over square root of 49? Well, square root of 49, isn't that 7? So 7's on the bottom. Square root of 20 is 2 root 5. And then you multiply it, right? 7 over 1 times 2 root 5 over 7. 7's cancel. And I just have 2 root 5. Okay, same thing. 3/4. So you can leave that on the outside. And that's root 8 over 1. So that's 2 root 2 over 1. And then I can cross cancel. That's a 2 and a 1. So I have 3 root 2 over 2. Okay, this one, don't forget guys, there's a 1 in front of here. So it's 1 root 5 minus 3 root 5 is negative 2 root 5. Okay, root 28 is the same thing as 7 times 4, which is 2 root 7 plus 2 root 7 is 4 root 7. Please don't tell me it's 4 root 14. Okay, it's like saying 2x plus 2x is 4x. Okay, if I have 2 root 7s, I have another 2 root 7s. I have 4 root 7s. All right. This one, remember, you can't add unless you have the same number under the radical or the same radicand. So just simplify each one of these. 18 is 9 and 2. So I can pull a 3 out. That gives me 3 times 3 is 9 root 2. And 50 is 25 and 2. Square root of 25 is 5. So 10 times 5 is 50. So minus 50 root 2. So 9 root 2 minus 50 root 2 is basically 9 minus 50 is negative 41 root 2. Okay? The next one, 3 root 9. Well, root 9 is 3. So 3 times 3 is 9. That's easy. Plus root 20 is 4 times 5. Square root of 4 is 2. So 2 times 2 is 4 with a 5 left over. And 9 times 5 is 45. So you take a 9 out. Square root of 9 is 3. So minus 3 root with a 5 left over. And I can combine these together. That's the only ones I can combine. So it's 9. 4 root 5 minus 3 root 5 is plus root 5. All right, getting there. Root 6, can't do much with that. So what I'm going to do is, the only one I can simplify here is this guy. So it's square root of 1 over square root of 6, which is just 1 over root 6, and then I rationalize. So multiply the top and the bottom by root 6 over root 6. So that gives me root 6 plus root 6 over 6. All right, and the only tricky thing about this one is I want to get a common denominator. If you guys remember back in the day, math fans, to get a common denominator, don't you multiply this by 6 over 6, right? And now I have a 6 on the bottom, so I have 6 root 6 plus 1 root 6. Isn't that 7 root 6 over 6? Okay. Next one is root 1 over root 2 minus root 3 over root 4. So isn't that 1 over root 2 minus root 3 over 2? Well, I need to rationalize this one, so I multiply this one by root 2 over root 2. So that gives me root 2 over 2 minus root 3 over 2, which you can't really simplify that one, so it's literally with the same denominator. It's root 2 minus root 3 over 2. Okay, the next one, root 200 is 100 times 2, so it's 10 root 2. Root 242, again, start dividing out, and it turns out 11 is a perfect square, so I can divide out 121 times 2, so it's minus 11 root 2 minus 1 root 2. They all have root 2s, so you just add them together. 10 minus 11 is negative 1, minus 1 is negative 2. Okay, root 8, it's 2 root 2, so take a 2 out. It's 2 root 2, right? It's 4 times 2, so take a 2 out, so I have 4, 2 times 2 is 4, with a 2 left over. 98 is 49 and 2. Square root of 49 is 7, so minus 7 root 2. And square root of 72, it's kind of one of those numbers. Let's do this on the side here. Isn't it 9 times 8? But remember, the square root of 8 can be simplified. So it's 9 times 4 times 2. So I pull out a 9 and a 4, so I get a 3 times 2 is 6. And I have a 2 left over. So they all have root 2. So 4 root 2 minus 7 root 2 is negative 3 root 2, plus 6 root 2 is positive 3 root 2. Okay, 38 is really easy. Square root of 1 over square root of 16. That's just 1/4. Okay, this one, before you rationalize it, I would simplify it, or before you rationalize, simplify it. So that's equal to 4 times 5, so 1 over 2 root 5, and then rationalize it. You're going to have to simplify it anyway at the end, so might as well do it early. So you get root 5 over 10. Okay, this one, I'm just going to rationalize it. So multiply it by root 2 over root 2. So it's 8 root 2 over 2, and that's a 4 and a 1, so it's 4 root 2. Okay, so you guys remember with variables, you basically take one away, so it's x times x to the 4th. So you remember you divide that number by 2. So it's x squared, and you have a leftover x. Okay, if you don't remember that, look over the notes. You guys are really good at that when we did that, so make sure you're good with it now. Square root of x to the 8th is x to the 4th, right? 8 divided by 2 is 4. And 6 divided by 2 is 3, and you got a leftover. Okay, so I have x squared y to the 4th. 7, well, it's going to be 6 divided by 2 is 3. 4 divided by 2 is 2. And you have leftover of x, because you only add number. And then x squared x times x to the 3rd is x to the 5th. Y to the 6th, square root of x. Okay, this one's easy. 20 divided by 2 is 10. 10 divided by 2 is 5. All right, number 45. You can't do anything with that xy inside here. Okay, what I can do is I can simplify the 8. So square root of 8 is 2 root 2. So it's 2x squared y squared. And left over is, remember, it's 2 root 2, so the 2's in here, and then the x and the y. And that's your final answer. Okay, this one, again, I'm going to write this 3x to the 5th, y to the 7th, and then I'll take the square root of 20 is 2 root 5, and there's a 5 left over. 12 is perfect, or 12 is an even number, so 12 divided by 2 is 6. And then put it all together. So 3 times 2 is 6, x to the 11th, y to the 7th, and I have a root 5 left over. Okay, 47, it's getting a little more evil and nasty. I can't do anything with the 10, but what I can do is, let me write this out, x to the 9x to the 4th, y to the 6th, z to the 8th, and I have a 10 left over. Actually, they're all even numbers. So that's x to the 4th, y to the 3rd, z squared. Okay? And then you multiply it all together. Don't forget you add your exponents. So it's 9 x to the 8th, y to the 9th, z to the 10th, root 10. And that's your final answer. Okay. 48, I have x, y, and z. It's a 3, so it's really a 2 divided by 1, so I can pull out basically an x, y, z. And I have left over each one of those because there's an odd number. And if I multiply that, it's x squared, y squared, z squared, square root of x, y, z. All right. 64, square root of 64 is 8. That's a perfect square. Comes out. 8 to the 9th, so it's a to the 8th divided by 2 is a to the 4th. B to the 4th divided by 2 is b squared. And that's it. I can't do anything with the c. But remember, there's an a left over, there's a b left over, and there's a c left over. Okay, this next set of problems is all solving, which we spent the last couple days doing that. Remember, you isolate the square root. So I'm going to add 2 to both sides, so I get the square root of x equals 9, and I square both sides. So x equals 81. Okay, please don't square root it. It's the opposite of the square root, which is squaring it. So you square both sides and you get 81. I mean, it's easy to check it too. You put in the 81 in that square root of x, so square root of 81 is 9, 9 minus 2 is 7. That's pretty easy. Okay, this one, square both sides. So 2x is equal to 1 over 25. How do you get rid of the 2? Don't divide by 2, especially when you have a fraction on the other side. Multiply by its reciprocal. So it's 1/2 and 1/2. So x equals 1 over 50. All right. Next one, it's already isolated, so that's squared. So you get x plus 4 equals 81. Subtract 4. X equals 77. Okay, this one, subtract 5. So negative square root of x equals 7. Divide by negative 1. Square root of x equals negative 7. Right there, people! NSB. Okay, after you isolate it, if it's equal to a negative number, you're done with the problem. Don't keep going. Recognize that. All right, I want to isolate that square root by the variable, so I can divide both sides by 2. And that's really nice because that cancels that, a 2 and a 1. So I get root 3x equals 2 root 3. And then I square both sides. So I get 3x equals 2 squared is 4, root 3 squared is 3. So 3x equals 12, divide by 3, x equals 4. Okay, this one, square both sides. So I get 2x plus 10. And then, don't forget, guys, write it twice. Okay, don't give me x squared plus 25. It's brutal if you do that, okay? And it's very sad, and I'll cry. So please don't just square the x and the 5. It's very sad. All right, so I get x squared plus 5x plus 5x plus 25. Okay, so I move everything to one side. We can combine, but So let's do that. 2x plus 10 equals x squared plus 10x plus 25. And then you subtract 2x and subtract 10 from both sides. So you get x squared plus 8x plus 15 equals 0. And then you got to factor it. So it's x plus 3, x plus 5. That was pretty easy. So x comes out to be negative 3 and negative 5. All right. Now remember, you should check to see if one of these if they both work. All right. When you're squaring things. So what I'm going to do is I'm going to plug it in the original formula, and I don't have room here so I'll just talk it out. 2 times negative 3 is negative 6, plus 10 is 4. Square root of 4 is 2. Negative 3 plus 5 is 2. So this one's good. Let's put the negative 5 in there. 2 times negative 5 is negative 10 plus 10 is 0. Square root of 0 is 0. And negative 5 plus 5 is 0. So 0 equals 0. So this one's good too. So those are my two answers. Okay? 56. Okay, I'm going to move that 6 over first. So I get square root of 7x plus 3 equals 0. Square both sides. So 7x plus 3 equals 0, square root of 0. And then you just solve it. So subtract 3 from both sides. So 7x equals negative 3. Divide by 7. X equals negative 3/7. Okay, that's not bad. Next one, I'm going to square both sides because it's already isolated. And I get x squared equals 8 minus 2x. So move everything to one side. So I'm going to subtract 8 and add 2x. So I get x squared plus 2x minus 8 equals 0. And then I factor. So you get x plus 4, x minus 2. So you get x equals negative 4 and x equals 2. And the original problem, I'm going to just erase this. The original problem, let's get rid of that, and that was that. X equals square root of 8 minus 2x. And what I want to do is, if I plug these values in now, let's plug the negative 4. You guys should recognize right away, you can't take the square root of a number and get a negative 4. So this is out of here. And at 2, 8 minus 4 is 4. Square root of 4 is 2. 2 equals 2. That's a good number. Okay? Next one, square both sides. So x squared equals 9x minus 14. Move that over, so I get x squared minus 9x plus 14 equals 0. So I subtracted 9x and added 14 to both sides. And then if I factor that, I get x minus 7, x minus 2 equals 0. So x comes out to be 7 and 2. And if you plug both of those values in, they both work. Okay, you just try that, but always plug them in to see if it works, and they both work. Okay, this next one, I'm going to square both sides. Again, write this twice, so I'm just going to even write it twice right away. Okay, so I get negative 10x plus 21 equals x squared minus 3x plus 9. That gives me negative 6x here. And then I'm going to add 10x to both sides and subtract 21. So I get x squared plus 4x minus 12 equals 0. And if I factor that, I get x plus 6, x minus 2 equals 0. So x equals negative 6 and x equals 2. Okay, again, I plug it back in my original problem. The negative 6 doesn't work. Let me erase this a little bit here now on top. This was my original problem. There we go. Okay, and if I plug a negative 6 in there, negative 6 minus 3 is negative 9. That doesn't work. And 2 minus 3 is negative 1. That doesn't work. You can't take the square root of a number and get a negative value. So none of these work. So the answer to this one is NSB. No solution, baby. Okay? Very important. All right, last two here. Solve using the quadratic formula. Give exact answers only. Okay, so you want to be able to give an exact answer and also a decimal approximation. But let's do exact, and actually we'll do approximation only, or approximation with that. So A is 3. Oh, by the way, it's set it equal to 0 already. That's important. B is equal to 8, and C is equal to 3. So it's x equals opposite of B, plus or minus the square root of 8 squared minus 4 times 3 times 3, all over 2 times 3. So x equals negative 8 plus or minus the square root of 64 minus 36 over 6. So x equals negative 8 plus or minus 64 minus 36 is 28 over 6. And then I can simplify that. It's negative 8 plus or minus, it's 7 times 4, so 2 root 7 over 6. All right, now this is the deal. You just write it as two fractions. So x equals, it's negative 8 over 6 plus or minus 2 root 7 over 6. So 8 over 6 is negative 4/3. And that's a 1 and a 3. So it's plus or minus root 7 over 3. Okay? That is your exact answer. If I want a decimal, you're going to do it right here. Before you split up, guys, stick that in your calculator. Okay? And I'm going to do that right now as we're talking. It's negative 8 plus 2 root 7 equals, divided by 6 equals. So negative 0.45, rounded to 2 decimal places. And I'm going to do the exact same thing, except I'm going to do negative 8 minus 2 root 7, hit equals, divided by 6, negative 2.22. Okay, so make sure you know how to do both, rounded and exact answers. Okay, so this one's already solved too. Just remember, if that was like equal to 5, you'd have to subtract 5 from both sides, but it's all good to go. And A is 2, B is negative 2, and C is negative 5. So x equals opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So it's 2 plus or minus the square root of 4. And that gives, guys, just be careful with signs. It's negative 4 times 2 is negative 8 times negative 5 is positive 40. Okay, don't mess up the signs. All over 4. So x equals 2 plus or minus square root of 44 over 4, which is 2 plus or minus, we take a 4 out, so it's really taking a 2 out, so it's 2 root 11 over 4. Split up into two fractions, 2 over 4 plus or minus 2 root 11 over 4. And that gives me 1/2 plus or minus root 11 over 2. Okay? And that is your exact answer. If I want to do a decimal approximation, again from this point right here, math fans, 2 plus or minus 2 root 11 over 4. Okay, so I'm going to do it right now. 2 plus 2 root 11 equals, divided by 4 equals, so 2.16. And same thing, except 2 minus 2 root 11 divided by 4. And that gives me negative 1.16. Okay, be careful if you're rounding, because I'm going to take off if you round incorrectly. And those are your two answers. Okay? So that's not too bad. It's a lot of little rules to remember with all these different problems, and you got to go back and look at all your worksheets, and you should be good to go. All right, math fans, that's it. Have a good day. Adios. Bye-bye.